A very good afternoon to one and all present. Today my lecture is on advanced features of Prolog programming, and the target audience of this lecture is 7th or 8th semesters CSE branch students having the subject symbolic logic and logic programming. See, before actually coming to advanced features of Prolog, let us see what basically Prolog is, then we will come forward to the advanced features. See, Prolog as the abbreviation stands for programming in logic. It is basically a programming language for artificial intelligence and non-numerical programming in general, and this term is important, and this is basically used for non-numerical programming. No big complex calculations are there by using Prolog you can solve. Prolog is a computer programming language that is used for solving problem that involves objects and the relationships between the objects. This language tries to explore the various objects and their relationships. Prolog is basically a conversation language. Conversation means, for example, when you go to an ATM machine, you enter your card, it asks you for certain questions. Let's say enter your PIN. Okay, or what is the language of mode of language, whether it is English, Punjabi, or Hindi. Means you make some sort of conversation between the computer and the human. And Prolog language is basically suitable for such kind of applications, which means that you and the computer carry out it is written, carry out a kind of conversation. Prolog is a logic based language. Everything is in logic. With a few simple rules, information can also be analyzed, that we will see in the next slide. When you write a Prolog program, it is to be written in Notepad, and when you will save this file, it will be saved as .pl. That is stands for Prolog file. It contains a list of clauses. Now, this clause can be either a fact or a rule in Prolog. For example, what is this? Male Bob. It means Bob is a male, and it is ended with this dot. This is a fact. This is another fact. Harry is a male. This is another fact having two arguments now. Bob is a child of Harry. This is how it is to be read, and this is a notation for rule. X is a son of Y if it is to be read as if X is a male, and it is to be interpreted as and X is a child of Y. Let us again do it, and this is known as a fact or a predicate with arity 1 means there is only one argument. This dot is used to terminate a clause, whether it is a rule clause or it is a fact. It indicates a rule. This is the argument to predicate, and it is to be interpreted as and. It means X is a son of Y if X is a male and X is a child of Y. Only then this rule will be important. Now, let us formally discuss what basically fact is. It is a statement that is implied in the program. For example, thief Deep. Deep is a thief. For example, another fact is Mary likes water. This is how to be interpreted as likes Mary, water. And see, here is the dot. This is used to terminate either fact or rule. Rule is basically when you want to represent the same knowledge a number of times, you need to give the generalized statement. Otherwise, the list of facts will be very huge, and that will increase your size of the database. So, this is basically a generalized statement that helps for deducing something. For example, X is a sister of Y if X is a female and the parents of X are M and F, they are denoted by M and F, and parents of Y are also denoted by M and F. See, the same variables are used over here, the same variables are used over here. That is why if X is sister of Y, both of X and Y should have the same parent. This is another example of a rule. Now, rules combine facts to increase knowledge of the system. For example, X is a son of Y if X is a male and X is a child of Y. This is how to be interpreted. Now, what to do with this collection of clauses, collection of facts and rules? We can ask the Prolog virtual machines a number of questions. For example, how to ask the question? They are composed at this prompt. When you have saved your program as .pl file, just double click that file. When you double click that file, this sign will come like this. Here you can write your query. For example, you want to check whether Bob is a son of Harry or not. The answer of this question will be in the form of yes or no. If the answer is yes, means this knowledge has been deduced from the program itself and this knowledge is present. If the answer comes out to be no, it does not mean the question you are asking is wrong. It just merely means the information is not present in your program in the form of facts or rules. So, it has to be clear. No does not mean that this is false. We can bind answers to questions to variables. For example, if you want to check who is Bob the son of, we will ask the question Bob is a son of X. Here X is the variable. When you ask this query, the answer will come X is equal to Harry. Who is male? You can ask the question male X. Whatever the different values of males are, they will be printed as X is equal to Bob, X is equal to Harry. Is Bob the son of someone? Son Bob. Here we have not written any variable. It means this is known as don't care condition. If we don't care whatever the value of variable is, it should have certain value. The answer will be in the form of yes or no. No variables are bound in this case. So, the answer will come in the form of yes or no only. See, this is we will go in detail how Prolog actually comes out to the answer. We will take one example. We want to check X is a son of Harry or not. We want to know this value X. Now, when it will come out to the program, it will match with this rule. Okay. The value of X is here, the value of Y is Harry over here. So, we want to check that value of Y over here, the value of Y over here is now is Harry. Y is bound to the atom Harry by the question. So, it means male X, child of X and Y, here Y is Harry. The value of X can be, it can be anything right from the starting of the rule. If the value of X is, if you go back to the program, here male, the value of male is either Bob or Harry. Right? If value of X is Harry and Y is also Harry, Harry is a child of Harry. No, logically this is incorrect. So, the answer has to be no. If X is equal to Bob and Y is equal to Harry, child Bob is a child of Harry. Okay, yes, it succeeds. Okay. So, let us again do in detail what are the different queries we can put with the Prolog. It is a statement that we want to deduce from the given facts and rules. For example, if we want to check what are the different things that John likes, you can put a query like likes John comma X, we will get the different values of X. Who is the prince of USA? Here we can get the value of this variable X. See what actually a Prolog does, how it actually executes the program. There is a concept of place markers. Place marker is a checkpoint where the Prolog program is currently focused. We will take this example of a program to explain the concept of place markers. Here in this our program, we are having 4 facts. John likes food, John likes wine, Mary likes wine, Mary likes ice. So, and we put the query likes John comma X, likes Mary comma X. Can you tell me what is the meaning of this query? It means what is the common in between John and Mary? Whatever John likes, that has to be same as whatever Mary likes, and the answer comes out to be wine. See the program. John likes wine, Mary likes wine. There is one common thing in between the two. That's why the answer is wine. Now, how this answer came? Let's see. See, when the searching start for this fact, let me tell you, whenever there are number of sub goals, this complete is known as a goal. There are 2 sub goals likes John comma X and likes Mary comma X, and the execution always starts from the left hand side. That's why we will take this first sub goal, it will match with the first fact, and this is the place marker. The variable X is instantiated to food. That's why X is equal to food. It means likes John comma food comma, and the same variable X over here is likes Mary comma food. So, it succeeds. Let us see, it succeeds or not. It is present in the facts. No, it is not present. Marry wine, marry ice. No, it is not present. So, what will happen? It will backtrack to the another value of x. This first place marker, now it comes from this fact to this fact. Now, the value of x will be wine. Right. Now, likes John, wine, and likes Mary, wine. It succeeds, and let us see, it is present in the database of x or not. Yes, it is present. It has to be matched. Searching which starts from from the scratch, from the beginning. It will match with this. No, it is not matching. It is not matching with this one. Okay, it will match with this Mary, wine. It is found over here. That's why the answer comes out to be x is equal to wine. Now, what basically how a Prolog, your Prolog interpreter or Prolog compiler executes your program. So, while executing Prolog goal, leftmost goal is chosen instead of an arbitrary one, as is done in logic programming. This is one of the difference between Prolog and the logic programming. In logic programming, if there are a set of sub goals, you can satisfy anyone, but as far as Prolog is concerned, the leftmost goal is always chosen for execution. Prolog is non-deterministic in nature, because a goal can be satisfied using more than one rules. For example, there is a rule whose head of the body is A is true if B, C, D is true. There is another rule having the same head A, and it is satisfied when P and Q are true. For example, you have got the query is A. Okay, it will match with firstly with this one. To execute, it is replaced with B, C, and D. You get one answer when B, C, and D are satisfied. Okay. When you again press semicolon, why I am saying semicolon? If you want to get more than one answer for the same query, press semicolon and press enter. If you press semicolon, it will give you the another alternative answer for the same rule. Once it has got the answer for B, C, D, then you press semicolon, it will automatically move to the next rule. It means one goal can be matched with more than a number of rules and facts. It all depends on what knowledge you have in your program. There are three phases or three processes, you can say, that takes place while executing a program. These are forward movement, matching, it is also known as unification, then backward movement, that is also known as backtracking. Let us start with the forward movement. What it is? Choose a rule by searching sequentially. Sequentially means one by one in the program from top to bottom, whose head matches with the goal with possible unifier. Remember the position of the matched rule, that is, place a place marker at that point. That we have already, I have already explained in the previous slide what is the concept of place marker. So, wherever you have matched the goal with some rule or fact, place a place marker at that point. This is how the Prolog compiler remembers from where to start the searching. Then join the rule body in front of the sequence of the sub goals to be solved. Like in the previous example, if your query is A, now the query will be replaced with B, C, and D. Now, instead of satisfying A, we will try to satisfy B, C, and D. Repeat the above steps until either the goal is satisfied or is failed, and the process continues. Unification, basically what it is? Unification is a process of matching and finding the most general unifier. Constant matches with the same constant, a variable matches with any constant and become instantiated. Likewise, in our previous examples, let us say there was a variable x. When x is initialized to some value, we say x has been instantiated. A variable can also matches with another variable, and this is to be noted. And the third, rather I should say the foremost, most important process or phase of Prolog programming execution model is backtracking. Backtracking in Prolog takes place in basically two situations. First situation is when a subgoal fails. When a subgoal fails, you backtrack to the previous subgoal. Okay. And the second situation is if the last subgoal succeeds, it means when the last subgoal succeeds, you have got the answer. To get the alternative answer, we will press, what we will press? Anybody? Okay, we will press the semicolon. Then again the system will backtrack to give you more answers. Now, based on two conditions, we are having two types of backtracking as it is written over here, shallow backtracking and deep backtracking. Shallow backtracking क्या है? It occurs when the last subgoal succeeds. It means when you want to find alternative solution, the last subgoal is tried to be unified with another rule or fact from the last place marker. What is this last place marker? From where the backtracking will take place. It will not take place from starting of the database of facts. Then another type is deep backtracking. It occurs as a result of failure as shallow, in which it backtracks to the previous subgoal. This is the condition when a subgoal fails, we say there is deep backtracking. It removes bindings generated by the subgoals introduced due to the current subgoal. Yeah, that's correct. Okay, here let us say C over here fails, then it will backtrack to B. No, whatever bindings of B were having, they will be removed. It will go for another value B, and then it comes back again to C. Now, if you try to explain the three phases, forward movement, unification and backtracking from this example, see, to satisfy A, we have to satisfy B, C and D. First B will be satisfied, then C will be satisfied, then D will be satisfied. What is this? This is nothing but a forward movement from here to here to here, you are moving forward, right. Unification means matching of all of these subgoals with the facts present in the source program. That step is matching. And if I got the one answer, if D succeeds, that it means you have got one answer. It means which type of backtracking it will occur if you want to find alternative answer. That will be shallow backtracking, right. And if D fails, where it will go? It will go to C. It will try to find the alternative value for C, and then it will again come back to D. And if whole of this B, C and D fails, then it will come to alternative rule, that is it will try to satisfy P and Q. This is how a Prolog execute the program. Prolog compiler executes the program. This is what we have covered. Now there are number of facts and rules in our program, that is the database of facts and rules. If the number of facts and rules are very large, you can't go for linear searching only. Linear search, all of you remember, okay, search one element at a time in sequential mode, that is not linear search. Now, what is the search strategy of Prolog? How it manage the large huge database of facts and rules? Searching is a major issue in in almost all programming languages. There are many ways to search for a solution to a problem. What Prolog interpreter does, it uses a method known as depth first search for matching facts and rules. Now, if you remember the concept of graph search methods, there are two methods. One is depth first search, and the another one is, yes, anybody? Yes, breadth first search. And the Prolog interpreter uses depth first search. Okay, and this is the example, how we will explain this depth first search. Depth first search starts searching from the initial node deep down through one branch in depth first fashion until it reaches to a final goal or node, whatever it is, or if it is not possible to proceed further, then it backtracks to immediate previous node and repeats the process in depth first fashion. It terminates if the final node has been reached or all the nodes have been explored or have been visited. For example, let us say we start with this A. To find the solution, we will first explore this whole branch of the tree, of the graph, sorry. A, from A to B, B to D, D to H. This is flow of satisfaction. After H, it will move to this branch, because there is no branch in between, B to E, E to first this one depth, then here, then it will again backtrack to A to the other branch, here, 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 then here. And you can see our Prolog interpreter first looks into the depth. It does not look for width from A to B, B to C, then B to D, E, F, G. This is what the breadth first search is. And here the Prolog interpreter uses depth first search. I think it is clear right now, and we will I will also explain in the next slide by taking one example. See, as far as queries are concerned, there are two types of queries that you can put on and Prolog interpreter's interface. One is ground query and another one is known ground query. Ground query, what it is, if your query includes or consists of only constants, let me tell you, anything that starts with this small letter is a constant in Prolog, and anything that starts with capital letter is a variable. So, if inside your query, if there are only constants, then it is a ground query, and if it contains at least one variable, then we say it is a known ground query. One or more variable means it is a known ground query. And what your Prolog interpreter does, it creates a proof tree if it is a ground query, and it creates a search tree if it is a known ground query. Proof tree means you are given with the constant values, you want to prove it. Can anybody tell me what will be the format of the answer for this particular query, this ground query? It means Henry likes Joyce, yes or no. The answer will come in the form of yes or no only. Like in the known ground query, it will, you have to give the each and every value, possible value for this variable x, right. That is why that name is search tree. And proof tree means you want to prove, you want to give a proof whether this Henry likes Joyce or not. Let us see, let us take the one example of a program to illustrate depth first search concept. Here are a number of rules and facts. It means x is the grandfather of y if x is the father of z and z is the parent of y. X is the parent of y, there is another rule if x is the father of y. There is another rule having the same name, x is the parent of y if x is the mother of y. And there are a number of facts given with values. James is the father of Robert, Mike is the father of William, William is the father of James, Robert is the father of Hansi, Robert is the father of Chris. You can have a number of facts to explain your program. Let us assume that our goal is grandfather x comma y, means x is a grandfather of y. It means first tell me whether it is a ground query or non ground query. If it is containing only constants, no, both are variables. So, that is why it is a non ground query. It means a search tree needs to be created. See, here is the search tree for this particular goal, particular query. Let me explain this. X is a grandfather of y. Obviously, it is matched with, what is this 1, 2, this thing? It means it has been matched with the clause number 1 of your program. Where is the program? This is the clause number 1, grandfather x y. There is no other rule or fact having the same head. So, it is matched with this one. Then it is replaced with father x z comma parent z y. Father x z, firstly it matches with the second number clause and these are the possible bindings at this point. The value of x is James, then the value of z is Robert. And it is clear from the program itself. If x is James, z is Robert, it is true, and we are left with this one, parent Robert comma y. Okay, it is matched with again with the second one and the third one. There are two possibilities for this parent. If you look at the program itself, there are two clauses having father Robert Hensey, father having Robert as the first argument. See here, Robert y, parent Robert y, and sorry, parent is replaced with, see here, there are two clauses of parent, one will be replaced with father x y, another one will be replaced with mother x y. That is why there are two clauses over here, father Robert comma y and mother Robert comma y. There is no clause like this, it fails. It succeeds giving y value of y is equal to Hensey and y is equal to Chris. If you look at what which answer will come first out of Hensey and Chris, as the prologue is using depth first strategy, see this is the branch that is followed firstly, this one, it means the first answer that will come into picture is y is equal to Hensey. And then if you press semicolon, it means you are backtracking to the previous sub goal, it will give you the another value, that is y is equal to Chris. If you again press semicolon over here, it means you need to backtrack. This branch is not giving any solution, so you will backtrack over this place, and if it will find the alternative value for x and z like this, and this branch is giving another answer, y is equal to James, and it is failing. Now, from this example of search tree, it has to be clear what is the purpose of a search tree. It gives you all the possible outcomes or the solutions of this particular goal, right. So, search trees is the detailed tree which will give you all the alternatives, all the possible branches that it can take to find the successful answer. I think I am clear with the concept of search tree now. On backtracking we will get these answers, and you can see first answer kaun sa aaya, x is equal to James and y is equal to Hensey. X is equal to James from here and y is equal to Hensey. Second answer has to be x is equal to James, y is equal to Chris, like this. Okay, so it is clear from the search tree given above that prologue follows depth first search, that is searching from the initial node deep down through one branch in depth first fashion until it reaches the final node, or it is not possible to proceed further, then it backtracks to the previous node and then again starts in depth first session. So, let us take one more example. This is a program that is used to calculate the factorial of a number. The factorial of n is r. It succeeds if n is unified with the factorial of r. Factorial of 0 is 1. This is one fact. This is the rule. How to calculate factorial, you need to subtract the value of this variable by 1, store in some variable, and calculate the value of intermediate variable, and then the final result will be the number itself and the result of the intermediate variable. So, this is rule 1 states factorial of 0 is 1, which is terminating clause. Rule 2 is a recursive clause which states that factorial of n is calculated by multiplying n with factorial of n minus 1, and you can see over here almost all prologue programs are based on the concept of recursion. If you remember, recursion means when a function call itself, but with different value. This is the name of the function, let us say, just imagine it is a function having two arguments n and r. See, and again the same function is called having now different values. So, a prologue program it is based on the concept of recursion. So, this is the example. We want to calculate the value factorial of 3, the result will be produced by this r. Okay, it is matched with the second clause. There are two clauses only in the program, and this is the possible binding, n is equal to 3. Now, n1 is n minus 3 minus 1, this is 2, factorial of n1 is r1, r is n cross 3. Now, it succeeds, it means value here is 2, n1 is equal to 2. So, it again matches with this one. Now, n2 is again n1 minus 1, 2 minus 1, 1, factorial of n2 is r2, r1 is n1 cross r1, and this remains as such this thing. Firstly, it will execute it. It means n2 की value कितनी आ गई 1. It means n3 is 0, 1 minus 1 0, factorial of n3 is r3. These are the names of intermediate variables that you keep on incrementing, you know, with each and every call of the function. R2